In this section, we will discuss two measures of central tendency, the mode and percentiles. The mode. The mode is the measurement in your dataset that occurs the most frequently. If you have exactly two numbers that occur the most frequently, then your problem is considered bimodal. If your dataset has more than two modes, then your dataset would be considered multimodal. The mode is often used to describe qualitative data, since you cannot compute the mean or the median for this data. In this dataset, 450 would be our mode. 450 is our mode because this number appears 7 times. It appears with the highest frequency. In this data set, the numbers 20 and 30 are our modes. These are our modes because these two numbers appear exactly 2 times, which is the highest frequency. Our problem is therefore bimodal. Percentiles and quartiles. Percentiles provide information about how our data are dispersed throughout an interval, from the smallest to the largest value. Admission test scores for colleges are often reported in terms of percentiles. In short, percentiles are more important to use. Okay, let me start this again. In short, percentiles are more useful when it is more important for you to understand how values in a population fare as compared to other values in the population instead of receiving a raw score. For example, if you took an SAT test and they simply reported that you correctly answered 72% of the questions, this information would be much less meaningful than it would if they reported to you that you scored higher than 90% of the students that took the same exam. The pth percentile of a data set is a value such that at least p% of the items take on this value or less, and at least 100 minus p% of the items take on this value or more. Here we have basic steps for computing percentiles. First, arrange your data in ascending order. Second, you should compute an index I, the position of the pth percentile. I is equal to p divided by 100 times n. In step 3, it's divided into 2 parts. 3a, if I is not an integer, then round I up. The pth percentile is the value located in this position. 3b, if I is an integer, the pth percentile is the average of the values in position I and position I plus 1. When using these steps to compute your percentiles, you must remember that I simply helps you to locate the position of the pth percentile. You must follow all 3 of these steps closely in order to identify the actual value for our pth percentile. Let's explore this data set. For the data set in this example, let's compute the 75th percentile. In step 1, we should start by placing these numbers in ascending order. In step 2, we must compute the index I. Recall, I is equal to P, which is 75 in this case since we want the 75th percentile, divided by 100 times n, and in this case n is equal to 8 since we have 8 data values. 75 divided by 100 times 8 is equal to 6. According to our steps, since I is an integer, Rule 3b we should follow. Rule 3b tells us if I is an integer, we should locate the two numbers in position I and position I plus 1. And our pth percentile is the average of the numbers in these two positions. So first, we identify 46 as the number that's in position 6 and 50 as the number in position 7. If we take the average of these two numbers, we obtain 48. 48, therefore, is our pth percentile. So our 75th percentile for this problem is the value 48. For the same data set, let's compute the 90th percentile. Again, we start by placing our numbers in ascending order. In step 2, we compute I. I is equal to P, the percentile we're trying to find, divided by 100 times n, our sample size. So I in this case is 90 divided by 100 times 8, which equals 7.2. Following our steps, since I is not an integer, Rule 3a applies. Rule 3a tells us to round I up to the next integer. Please remember, we do not follow normal rounding rules for this rule. 3a tells us if I is a non-integer, round it up regardless of the value of I. When we round I up, 7.2 is rounded up to 8, and according to Rule 3a, our pth percentile is the value in this position. Therefore, 225 is the value in position 8, so our 90th percentile is 225. There are certain percentiles that pop up often when analyzing data. The first quartile is the name that we give for the 25th percentile. The second quartile is the name that we give to the 50th percentile. If you recall, the median is also the 50th percentile. Previously in notes, we did not identify it as a percentile. However, the definition of a median was the value such that at least 50% of the values are that value or less, and 50% of the values are that value or more. This exactly follows our definition of a percentile when P is equal to 50. The third quartile also comes up a lot in data, and we give this title to the 75th percentile. Let's get some hands-on practice with computing percentiles. For this data set, let's compute the first quartile, which is the 25th percentile, and the 70th percentile. You should pause the video at this time and compute these two measures. You should have started by placing your numbers in ascending order. In step A, when computing the first quartile, you should have computed I as 25 divided by 100 times 10, which is 2.5. Since I is not an integer, Rule 3A applies. We round I up to 3, and our first quartile is the value in this position. When we round our I value 2.5 up to 3, we notice that the number 60 is in position 3. Therefore, 60 is our first quartile. When computing the 70th percentile, you should have computed I as 70 divided by 100 times 10, which equals 7. Since I is an integer, Rule 3B applies. The 70th percentile is the average of the values that are in position I, which is position 7, and in position I plus 1, which is position 8. You should have looked through your data values and found that the number 67 was in position 7 and the number 70 was in position 8. The average of these two values is 68.5. Therefore, our 70th percentile is 68.5.